Okay, hello everyone. Thank you for joining us today and being interested in this interesting topic. And today we're going to discuss how to optimize the loading of your web application. And we're going to discuss some basic concepts such as core web vitals, process of painting actual on-screen pixels, and strategies and techniques for optimizing your application. Okay, but before we start, let me introduce myself. So my name is Alex. I'm a lead software engineer with 5 years of commercial experience with main focus on Angular and TypeScript. And currently I'm working on a project where I'm a team lead with 8 front-end engineers. So before we dive into some technical specs, I'd like to answer on an important question. Why does it matter? So why should we care about our performance? So the reason is simple. Improved load time enhance the user experience and keep them engaged and less prone to shifting to another site. So today we have a lot of competitors that have a lot of apps, and if you want to engage your user, you have to be fast, obviously. Sites with faster loading times have higher conversion rates, impacting sales and registration in e-commerce and other online businesses. So some companies did research and they revealed that every 1 second in delay for your rendering time reduce your sales by 7%, and there 40% of users will abandon your website if it loads more than 3 seconds. Search engines like Google consider page load speed as a ranking factor in their algorithms, affecting the visibility of the site in search engine results. So if you want to be at the top of the Google search or Yandex search, whatever, you have to be fast. Okay, now we're going to explore some basic concepts, and we will start from core web vitals. Sorry for blank screen, but it's only one image that I have found. So what is core web vitals? Actually, it's just a list of 3 metrics that Google team formed somewhere. And these 3 of them: largest contentful paint, interaction to next paint, and cumulative layout shift. So we're starting from interaction to next paint, and these metrics show us how fast your website interacts with the user. What I mean by interaction, so it can be clicks on buttons, some interaction with JS-powered control, etc. Cumulative layout shift, its a metric shows how many times and how many area it's affected when some rendered element change its position. And today's metrics that we are going to discuss a little bit deeper will be LCP, Largest Contentful Paint. So what is it? And why it's so important today? Basically, this metric shows us how fast we load our most valuable content for our user. What is fast? Fast is less than 2.5 seconds. As you can see, it's a good result, and everybody's site should strive to this metric. What is the most valuable content? In general, it just can be some text block or image or any media content. We will look at some examples. Here you can see some screenshots. In the bottom, we have an LCP element, and the green text is just a LCP each time when LCP like a considered element. So at the first screen, we have just 2 text, view stories and US. So in this screenshot, we consider visual stories as the largest contentful paint. And while we load some content, the LCP element changes. And in the final stage, we have some image that browser considered as the most valuable content for the user. The next example is pretty similar. We have some, it's a crunch. And while the future LCP element is loading, we have some others. Next one is Instagram, and the story around this is quite different because our LCP element have been loaded before the final step. So even if we load some other text, we found our Instagram logo as the most valuable content. And the last one is a Google search page. So when you type something on the search field, click search, and there's some process around him, and we get some images and the description. So description considered as the most valuable content. So LCP will be here, not here. Okay, we have seen some examples, and we're ready to discuss the CRP, critical rendering pass. As I said before, it's a process which browser process to render actual on-screen pixels. So what is going on here? First, when you enter to the website, you have to download HTML, and then HTML should be parsed in a DOM. DOM is like document object model. It's a tree-like structure where every node from HTML appears. Then, in parallel to this, we load CSS, and CSS also should be parsed in the CSS-ON. It's just the same tree structure, and this structure contains only styles for it forms just map from your CSS rules. And once DOM and CSS-ON are built, we can construct render tree. Render tree is also tree-like structure, but we have only like a visible content here and their styles. Then we can proceed with layout step, and this step just calculates the positions of your elements and their actual size. And the final step is painting. This step paints on-screen pixels. So this process of how your web page are rendered. Okay, we're ready to discuss some strategies and techniques for this presentation, and I have chosen some of them. It will be only 6. It's not techniques in the world. So, okay. It will be caching, CDN, asynchronous loading, formatting for image and video, minification, bundle reduction, and dependency management. We're starting from caching. And what is caching in general? You can think of caching like high-speed memory that usually it stores static files like CSS, JavaScript, images, yeah. And there are 3 types of caching. I guess everybody knows about browser caching. It's related to Frontend, our job. And the next 2 are about backend engineers, and it's still good to know about them. So server-side caching just pre-generate responses to identical API requests and get them if they are made. And database caching, like temporary storing some database query, so if identical queries are made, results can be quickly retrieved from this cache. Let's switch our gears for a moment, and we will see another usable technique for optimization is a CDN, or content delivery network. So we have here an example. But what is CDN in general? In general, it's just, sorry, I need some water. Okay. CDN is just a network from distributed around the world, the service. And in major situation, you have some application that has a server in the US, and for this application, all users around the world can have access. They use it. And without CDN, our user from Spain will try to access to our server all the way to the US. It's not efficient, so we introduce content delivery network. We just put some servers around the world, and when the same user from Spain will try to access to our application, the closest server in the Ireland will handle it. Okay. So the next one is about asynchronous loading, and usually, as a rule, browser parses your web page line by line, executes function after another function, and it's called like synchronous flow. Asynchronous flow fundamentally breaks the chain. In these examples, you can see how can we connect our script to the web page. So we have just usual script. It's a default behavior, and as you can see, we have green bar. It's HTML parsing. Then when browser meet the script, it should load it, and right after it, it should be executed. So it's break the DOM construction, not break, just interrupt. And as you can see, CRP DOM should be constructed to like for render tree, because without render tree, we can't render the page. And it's a problem, and for this problem, we have two solutions, just two attributes, async and defer. They do pretty similar stuff. They load script asynchronously, but defer it's a little bit better because it executes only after when the HTML, the whole HTML will be like parsed. But the async doesn't. It still interrupts HTML parsing. Okay, the next one is pretty simple, and it will be really short. For media content, we should always choose the right format for any particular case. Then I advise you to use compression tools. There are a lot of them. You can reduce your files without losing too much quality, or just use smaller files. Okay. And the next advice will be about lazy loading. So it helps to not load files until they appear on the user viewport. So it's a pretty useful technique. Minification, I guess everybody knows about the minification, and it should be included into your build time, during your build time. So what is minification? Minification is just a process when we eliminate some code without affecting its functionality. I mean, we can remove comments like any white spaces, or reduce variable names, or even function names. So we decrease our files, and smaller files mean less data needs to be transferred over the network, and we can quicker load our page. So if our files are small, we can parse them quickly, and hence improve the overall performance. And in addition to this, we reduce the network bandwidth. Okay. Bundle reduction. So what is bundle in general? So bundle is just a bunch or one, just one is if you have one script, it's bad. It's better to split your code onto smaller chunks. And let's back to determination. What is bundle? Is just a generated production code of your web application. So use code splitting, divide code into smaller chunks, and load them lazily. But we can also choose another loading strategy that will be more suitable for a case, like a preloading, for example. And tree shaking, it's a widely used technique in computer science. It's elimination dead or unused code from the final bundle. All modern builders support this feature, but be aware of this feature only works with ES6 syntax, so be sure that you do not use require. And the last one is dependency management. So you should import only what you need. Try to import separate function instead of importing the entire library. Audit your dependencies. You can use such tools as Webpack Bundle Analyzer to determine which dependencies are adding significantly weight to your bundles. And one more advice at this point, it's update your dependencies regularly, because some updates can consist of like optimizations or removal some code. And use lighter alternatives. For example, we have several libraries for data, like working with data, like Day.js or Moment.js. Moment.js and Day.js are pretty similar libraries, but Day.js is compressed one, so it's much smaller. You can use Day.js and save some hundreds of kilobytes. And the next case is quite rare, but make sure that there are no duplicate dependencies in your bundle. Okay, actually, when I finished with strategies and techniques, and I'm ready to share my personal exercise from the current project. So when I came to current project, it was October 2022. And as you can see, our LCP was 3.3 seconds. And as you remember, our LCP values, the good one is 2.5 or less. So the result wasn't good, so we got a task from management team to improve this situation. I took this task personally and started investigation. So the first thing that I revealed was enormous bundle size. It was around 8 megabytes, and for like 6 megabytes of them was only our code, like project code, without dependencies. It was just like one big JavaScript file at all. So we started with code splitting and lazy loading. By this technique, we reduced our main.js file to 300 kilobytes, like 20 times. And what we did with dependencies was like 2 megabytes. Some of them we removed because they were redundant. Some of them we migrated to the lighter alternatives. And some of them were tree-shaked because we used code splitting. Also, we enhanced our caching mechanism and improved our geo-distribution. And also, we did some code optimization for reduce main thread. And before I say you thank you, I want to provide some roadmap or just a checklist how to start. So the first thing that you can do is analyze your current state, analyze your project. Lighthouse extension and Webpack Bundle Analyzer can help you. Apply the most suitable techniques for your case. So today we discussed some of them, but the world of optimization does not consist only from them. And the most important one is continuously measuring. So store the core metrics for your project. It can be LCP, PLT, NP, whatever. And continuously check them, because it's very important to collect them from real users, because you can have some like a more powerful laptop or better Ethernet connection, but the average user has some quite different case. So that's all from my side. Thank you so much for your attention.